Hello, gals and guys, and happy absolute maximum day. Today being Wednesday, some people will perhaps call this hump day, but if we look at a hump, the highest point there, right, we call that the absolute maximum. So perhaps trying to give Wednesday a mathematical name, happy absolute maximum day. Anyway, the first thing I'd like to do before we get into today's material is just talk about extra help, perhaps. I know that some people have asked me questions and I responded to them, but the district has allowed us to meet with you guys live over Google Meet. And so I know some of the material can be a little bit challenging. So if you would like to meet for extra help, just let me know, and we can set up a time to meet live over Google Meet, and I can answer any of your questions that you may have. So for today's lesson, we're going to do something referred to as a z-score. And as always, today's lesson, you can find the worksheets on Google Classroom if you want to print them out to take notes as I go through this z-score lesson. So the first exercise we're going to do, we're going to compare each pair relative to their gender. And you see here on the right side, these are various Disney characters that are all male with their respective sizes in inches. And then this here is a listing of all female Disney characters and their respective size in inches. So first, who is taller, Belle or Maleficent? When we look at their sizes, I think we would agree that Maleficent is taller. And I think I pronounced her name correctly. In two, who is taller, Dracula or Jafar? Well, Jafar is 78, Dracula is 79 inches, so actually Dracula is taller. And then three, who is taller, Mickey or Daisy? Where Mickey has a height of 64 inches and Daisy has a height of 63 inches, so actually Mickey is taller. Now, Mickey is considered a short man, but Daisy is considered an average woman. Is this a fair comparison, considering that Mickey was actually taller? And I would claim yes, but yes based on gender. And this starts to get into the whole idea of what a z-score ultimately is going to do. Because to compare heights between two males, okay, that's one thing, that's fine because they're the same gender, or two females to compare uh, their heights, again, that's okay because they're the same gender. But to compare a male versus a female in their heights, well, now we're going across genders, and that may not be as fair of a thing to do. And so a z-score, what that tries to ultimately do is it tries to bring things that are perhaps in different groups and bring them all down to the same level playing field so that we can actually do a comparison. So the first two questions are more easily answered than the third because we have the same gender in the first two versus the third one. And so a more useful question, perhaps, for question number three may be who is taller with respect to their group? Right? Because, again, Mickey is short as a man and Daisy's average as a woman. If we compare things that way, then we would say that, oh, well, technically Daisy is actually a taller individual based upon their own gender. All right, so to continue working with the heights of our Disney characters, we'll look at another way to compare those heights. And so what we have here are the mean or average heights of both males and females in the United States, and we have their respective standard deviations. And if you recall from Algebra 1, a standard deviation kind of just tells us how spread out our data is from the mean. Now, using this information, we're going to create number lines for both males and females on the number lines here. And in the middle, we're going to plot the mean value to each of these respective heights. And then each interval out from the mean, that's again going to be one standard deviation. So if we start with the men, their average was 69.1, and their standard deviation being 2.9, I'll just add 2.9 to go from one interval to the next. So this here, this should be 72, and then this here should be 74.9, and then this here should be 77.8. And then going down from the mean, right, we're just going to now subtract 2.9 each time to get the next value. So this value here should be 66.2. This value here should be 63.4, or 3, I'm sorry. And then this value here should be 60.4. And I think I got that right. Now for the females, their mean height is 63.7, so I'll put that in the middle. And now we're going to add 2.7 each time I go out one increment. So that would mean this here should be 64, that should be 66.4. And then this here should be 67, should be 69.1. And then 69.8, that should be, this here should be 71.8 on this end here. And then working backwards from the mean, right, we subtract 2.7 each time. So this here should be 61, and then 60.3, this should be 58.3. And then 2.7 subtract from this here, that's 57.6, this should be 55.6. And so we have our number lines all laid out. And now what we'll perhaps do is we'll take the different Disney characters and put them accordingly on our particular number line. So I'll start with the males. Goofy was at, and I'm going to abbreviate, Goofy is just G, Jafar, J, Donald, D0, or DO, Mickey is going to be M, and Dracula will be DR. So Goofy had a height of 72 inches, so Goofy's right here. Jafar had a height of 78 inches, so Jafar would be about over here. Donald, 69 inches, so Donald is just right below the mean. And Mickey, 64 inches, so Mickey is about here. And Dracula is 79 inches. Dracula is just slightly taller than Jafar. And then for the females, Maleficent is 72 inches, so I'm going to put her right here. And actually, I'm going to just, Maleficent will be M, Belle, oops. So Maleficent will be MA, Minnie will be MI, Cinderella, and Daisy. So Maleficent MA. And then, let's see, Belle had a height of 67 inches, so Belle will be right here. And then Minnie had a height of 60 inches. Wrong way. So 60 inches would be right here for Minnie. And then Cinderella 69 inches. Cinderella will be right here. And then Daisy would have a height of 63 inches. And again, I'm going the wrong way. Daisy 63 inches. So Daisy's right there. And I think I have everything now plotted out accordingly on our number line. Okay, so now that we set up those number lines, let's try to actually do some comparisons of heights between our gender groups. So based on the number lines, who is in the extremes based on their gender? And so in the extremes would mean, really out on the endpoints. To the left, I hope we would agree that there really is no Disney character out here to the left. But out to the right here, we have three individuals that have really tall heights with respect to their genders. And those characters were Jafar, Dracula, and Maleficent. So I'm just going to write those Disney characters out here. Dracula and Maleficent. Now, who is further to the right, Maleficent or Jafar? Well, when we look at the respective names on their number lines, it looks like they're pretty much at the same spot here, right? One technically isn't further to the right than the other, even though technically Jafar's height is a higher value than Maleficent's. When we compare them with respect to their genders and their respective means and standard deviations, right, these are at about the same value. Number 9, who is further to the left, Mickey or Minnie? Well, Mickey is here on the male number line, whereas Minnie actually is here. So she is, I think it's clear that she definitely is further to the right, meaning Mickey is further to the left on their respective number lines. So that would be Mickey. And so, again, these number lines here kind of highlight the idea of what a z-score is going to do, because we have two different groups here, males and females, and to do comparisons between the groups to really put them on the same level playing field, we can do that provided that we know the mean of each set of data as well as the standard deviation of each set of data. Right? And if we know that information, we can do this here where everything gets put in the same level playing field, and then ultimately we can compare reasonably well between the two different groups. And that this z-score, which I've been referring to, the calculation that we use to calculate a z-score to a particular set of data will involve the mean of your set of data, which we refer to by using this abbreviation here. It looks like a U, but it's actually called mu. And we also use a standard deviation or calculation of a z-score, and the symbol we use for standard deviation is this funny looking symbol here. And so your z-score to any set of data, where x is that set of data, would be x minus your mu, your mean, all over your standard deviation, which again we use this symbol here to calculate the standard deviation, or to represent your standard deviation. And so this is your calculation to find the z-score to any set of data within a particular group. So now that we have the z-score defined, let's look at some more problems here. What does a negative z-score mean? Well, with this particular fraction, right, in order for it to be negative, it's really going to be dictated based upon the numerator. And so x minus mu would have to be something that's less than 0 for this whole z-score to be negative, which would mean that x would have to be less than mu, our mean. And so if x is less than the mean, I claim that we would be located, our score, our data score would be below, have to be located below the mean. In number 12, what does a positive z-score mean? Well, that would have the reverse effect here. If we're going to have a positive z-score, that would mean that your data score would actually have to be greater than the mean, and that would mean that you would be above, your data score would be above the mean on your number line. And then can the z-score be 0? I claim the answer here would be yes, and the only way this fraction can be 0 is that the mean would equal your data score, would equal your height of your Disney character. So right here, we would be at the mean. Okay, and so hopefully this here kind of highlights a little bit more exactly how the z-score works and how it can tell us exactly where we are located to the mean within a set of data. Okay, so now let's actually do some calculations of some z-scores of our Disney characters' heights. So this is our z-score calculation, and I'm going to start perhaps with Jafar. And to do the calculation, we need to know Jafar's actual height, the average of males, and a standard deviation. So Jafar's height was 78 inches. So I'll put that in here. So this is, say z is equal to our 78. And then we subtract from that the mean height for the males, which is 69.1. So minus 69.1. And then we put this over the standard deviation for the males, which is 2.9. And then we can punch this all into our calculator. And when we do that, we get a value of 3.07. So that would be Jafar's z-score. Now for Belle, I'll do the same thing. Calculate her z-score. So Belle's height, I'm going to first get that. Belle's height is 67 inches. So I'll write her z-score is equal to 67. And then I'll need the mean score for the height of females, and that's 63.7. And then this all goes over the standard deviation of the females' heights, which is this 2.7. And then from here, we can punch that all into your calculator, and we get a z-score for Belle of 1.22. So what I've now done is I've actually gone through and put in the z-scores for the rest of the Disney characters. If you want to practice that calculation out, you can do that, perhaps just to make sure you feel comfortable with the z-score calculation. But now that we have all these z-scores, now we can actually do our comparisons to see who may have has a greater height. So what can we say about the height of Maleficent compared with Jafar? Right, when we do the comparison now between Maleficent and Jafar, we see they have the exact same z-score, so we can say that they're equal. And then what can we say about the heights of Maleficent compared with Goofy? Well, Maleficent definitely has a higher z-score than Goofy, so we can say that Maleficent is taller. And then last, what can we say about the heights of Daisy compared with Donald? Well, Daisy has a negative 0.26 z-score, and Donald has a negative 0.03 z-score. And we have to be careful because remember, when we have a negative z-score, that means we are now to the left, we are below the mean. So I claim that technically, because Donald has a lower negative number, I claim that Donald Duck is taller than Daisy because with respect to their means, Daisy is going to be further to the left. She's going to be further below the mean than Donald. Okay, so I hope that this video helped you understand sort of what the z-score is. This is the formula that we have that we use to calculate any z-score. And the homework that I'll assign for Thursday, which I'll post my solutions to, you'll be working with this z-score for several of the problems. And the thing I'll say is that while you could be given all the information here to calculate your z-score, sometimes in a problem what may happen is that you may be given the z-score and perhaps the mean and your standard deviation, and then asked to solve for the actual data point. And to do that, you can still use the same formula to set this up, but then once you have it set up, you can perhaps cross multiply and then essentially solve for what this data value is. Okay, so you have your homework problem set for Thursday, and then what I'm going to do is on Friday, I will post a review sheet of just problems involving statistics as well as the independence that you guys learn within the probability section. And I'll post that on Friday along with my solutions, and then you can work on it. And then you can ask questions if you have any questions on that review sheet. And then next week, most likely on Monday, I'll post a quiz based upon the independence in probability as well as what I've covered in statistics so far. And that quiz on Monday, I think it'll be Monday, it'll most likely be due then at some point later in next week. All right, so if you have any questions on anything that I covered in this video or on any of the problems that you practice for this particular topic or on the review sheet, please let me know. If you'd like to have a live extra help session as well, just let me know as well, and we can set that up. And since this will be my last video between now and the weekend, I hope you have a wonderful weekend. And as always, please take care, stay safe, and I'll talk to you soon.